Hi, I'm Jen King, and I'm the technical lead on the Drive Android API. Today, I'm going to talk about the DriveEventService, which allows your app to respond to background events. First, we'll cover ChangeEvents, which notify you of changes to a particular item. Next, we'll introduce CompletionEvents, which tell you the outcome of a particular action. For example, whether a file you created was uploaded successfully. Last, we'll show you how to use CompletionEvents to resolve conflicts when multiple apps or multiple devices edit the same file. Let's get started. Some of you may already be aware of change event listeners, which allow you to listen for changes to a particular item while your app is running. But what if you want to inform users that a file they're interested in has changed while your app isn't running? The newly added change event subscriptions allow you to do just that. Subscriptions deliver exactly the same events as are delivered to a change event listener, but you request them and receive them in a slightly different way. To add a change event subscription, retrieve the Drive resource you're interested in, and simply call Add Change Subscription. But now you're probably wondering where these events get delivered. That's a good question. To handle background events, you need to create a service that extends DriveEventService and add this class to your app's manifest. You'll override the handler method in this class for each event in DriveEventService that you care about. Let's try this out. First, let's create the service class that will handle the change events. Create a class that extends DriveEventService. In this example, MyDriveEventService. Override the onChange method in your DriveEventService subclass and print out the event using log.d. This is where you should do any application-specific processing that you need to do. The last thing you need to do is define your service in the manifest so that the Drive API can find it. In Android manifest.xml, create an entry for your service. Set the Android exported attribute to true and add an intent filter for the handle event action so that Drive knows how to identify your service. Now, whenever an item gets updated by another app on the device, or the Drive API downloads changes from the server, your app will receive a change event. Now that you've got your Drive Event Service set up, you can easily add support for handling completion events. When you make a call to the Drive API, you receive a pending result with a status. The pending result status tells you whether this action was successfully applied locally on the device, but the action might not get sent to the server until later, for instance, if you're offline. Completion events let you know when the action has actually made it up to the server, if it was successfully applied on the device. You'll only receive a completion event if the original call was successful, meaning the pending result returned from that call had a successful status. Completion events themselves can result in either success, failure, or conflict. We'll start by looking at how to request these notifications and how to handle success and failure results. Completion events are requested for a single action, rather than for a single file or folder, like change events. To request a completion event, create an execution options builder, call setNotifyOnCompletion, and pass the new object as a parameter in your file creation or content update method calls. You can also add an optional tracking tag to the execution options to make it easier to identify which action the completion event corresponds to. To add a tracking tag, call setTrackingTag when you create your execution options. This tracking tag will be returned to you when the event is delivered. To handle events when they're fired, use the same DriveEventService class you created before and override the onCompletion method. You can compare the result of event.getStatus to CompletionEvent.statusSuccess to determine whether the action was successful. Similarly, check for CompletionEvent.statusFailure to determine if the action failed. For more info on what other data the completion event contains, take a look at the documentation for the completion event class. Last, once you've processed the completion event, you need to dismiss the event to acknowledge that you were able to respond. If your app can't process the event right away, for example, if your app is offline and needs to do a server query to process it, you can snooze the event. The Drive API will notify you about it again in the future. You should dismiss or snooze every event that you receive. In addition to success and failure, actions can also result in conflicts. Conflicts can happen when two apps on the same device edit the same file at the same time, or when a user interacts with your app from multiple devices. Let's take a look at how you can use completion events to resolve a conflict. Requesting a conflict event is almost exactly the same as requesting a standard completion event. The only difference is the conflict strategy. You set the conflict strategy using the setConflictStrategy method when creating your execution options. The default strategy, overwrite remote, overwrites any changes on the server. To respond to a conflict, you need to use the keep remote strategy to keep the remote changes. Conflict events are a type of completion event, so you'll receive these events in exactly the same way, using the onCompletion method of your DriveEventService subclass. If the upload results in a conflict, you'll receive an event with the status conflict. Remember to dismiss or snooze the event when you finish processing it. Each app will handle conflicts differently. You might be able to do a three-way merge, or you might want to ask the user. To get the server version of the file, open the file from the device as you normally would using drivefile.openfile. As long as you're online, this call will download the new version from the server. To get your modified version of the file, call getModifiedContentsInputStream on the completion event. Last, to get your original local copy before your modification was made, call getBaseContentsInputStream on the completion event. Now, compare the three copies of the file to create the merged version, write this content as you normally would using contents.commit, and dismiss the completion event. See our sample code for an example of merging items in a task list. You've just learned how to use the DriveEvents service to respond to change events, completion events, and conflicts. We can't wait to see what you build with these APIs. I'm Jen King, and thanks for watching.